Hiya! So in this video, we're going to be talking about orientations of a linear operator in particular. So we're going to start off with some linear operator P. So we start off with some linear operator P, and it's going to be acting on a vector space V. And we're going to let B be some chosen basis for our vector space V. And we're going to look at the image of this basis. So in other words, PB. So in other words, I use this operator on each of the vectors. Now, if P is non-degenerate, we know that this is a basis, right? So by P being non-degenerate, we're basically saying the matrix has non-zero determinant. So we know that this gives us a basis. In other words, since it has basis, we want to know what its orientation is. And this is not too hard to kind of see. What we do is we look at its matrix. So every linear operator has a matrix associated to it. In other words, we know that if P of B has a positive determinant, then B and PB have the same orientation. And if it has negative determinant, then they have opposite orientations. Right? So these are the kind of two things. Now, since the determinant of P, of the linear operator itself, is defined to be the same as the determinant of the basis, remember how it doesn't really matter, then what we have is precisely that if P has a linear operator is a positive determinant, then the action of P on the orientation of a basis preserves the orientation of a basis. The orientation of basis. In other words, if I have my basis and I operate on it by P, so I apply P to it, then I get a new basis with the same orientation as the original basis. It doesn't matter what my original basis was. We just know it's going to have the same orientation. Now, if the determinant of P is negative, on the other hand, so here positive, negative. If it's negative, then it swaps the orientations or changes the orientation, right? It changes from left to right or right to left. So in other words, what we can say precisely that P preserves the orientation. P preserves the orientation of V if the determinant of P is greater than 0. And if it's less than 0, then it changes or swaps the orientation of V. And that's it. So if P is some non-degenerate invertible linear operator, we can just do this and we're kind of happy from there. So I know this is going to be a shorter video. That's okay. I'd much rather have shorter videos. What we're going to do in the next video is look at orthogonal operators on the Euclidean vector space and kind of see where this takes us and how we can kind of do things from there. So let's look at some orthogonal operators in the next video, and I will see you then. Peace.